Hi everyone, in this video we will learn about shapes of compounds, shapes of covalent compounds. Um, Usually guys would say covalent compounds. Um, these shapes are based on a theory called valence shell electron pair repulsion theory. Yeah, I know it's a big name. Let me write it here. Okay, so we understand valence shell means the outermost energy level. It has electrons in it, and sometimes when we make a bond, those electrons are pairs, and um, equal charges repel each other. So that's all the theory is about. Electron pair, valence shell, electron pair repulsion theory. So again, the electrons that are in a bond, which is right here, this is valence shell of hydrogen, and they're both negative, so they repel each other. So if I have especially a central atom and it has electrons and electrons and electrons around it, and again electrons here, you know the dot diagram of NH3. So this is all negative. You know, if you realize we have negative electrons here, negative here, negative here, and negative here. The equal charges repel each other. So what this theory says that those equal charges, since they repel each other, they cannot stay at this 90-degree angle, you know, that we have right now. They're going to repel each other and push each other away at a distance where there is minimum repulsion between them. So look at the difference between this, that instead of having this 90-degree angle that we have been making between the two electrons, they repel each other, push each other away to a distance that there is minimum repulsion in between them. So that's all this theory is about. So we will just learn that if this is the dot diagram, then what would be the shape? Okay, now to figure the shape out, the concept behind is that if you have a bond pair, this is called bond pair. Okay, the one that has two electrons in it, bonded by the two nuclei on the two ends. So we got bond pair. So if I have two bond pairs, then the bond pair repulsion, okay, is less than the bond pair lone pair repulsion. Okay, this is the lone pair and this is the bond pair. So they are the free electrons. They can take much more space on the central atom. Okay, these are the bonded electrons. The nucleus of this nitrogen and the nucleus of this hydrogen is kind of holding them on spot. So, but what the theory is saying that if the nitrogen is here, then the repulsion between the lone pair, this is the lone pair, the repulsion between the lone pair and the bond pair is much more, okay, than the repulsion between the bond pair and bond pair. So bond pair repulsion is less, okay, than the bond pair lone pair repulsion, which is again less than the lone pair repulsion. So if I have two lone pairs, then they will even push each other further away. So bond pair between the bond pairs. So what we will see is that whenever we have more than one bond pairs, they will be squeezed together by the lone pairs. So the next we want to find out is that let's say if I have carbon and hydrogen, CH4, this is the dot diagram. We have already learned the dot diagram. So then we have a central atom. To decide this shape, we will only talk about the central atom. So if the central atom is surrounded by, let's take an example of this. If the central atom is surrounded by two, if the central atom is surrounded by two more atoms, okay, the shape is going to be linear. Okay, and the angle is going to be 180 degrees. Now, what is an example? We have learned the example of CO2. Okay, when we are doing the shape, we count single bond, double bond, or triple bond only once. Okay, this is another rule. We count single bond, double bond, and triple bond only once. So I know that it's a double bond here, but I only count once. So what I'm saying is that this is a central atom right here, and it is bonded on this side and it is bonded on this side. So if a central atom has two bond pairs, the shape is going to be linear and the angle is going to be 180 degrees. It has no lone pairs. Okay, so the way you will write is that it has two bond pairs and zero lone pairs. Because it doesn't have the dots on top and below. That's what the lone pairs means. So one more time, if I have silicon, I have a double bond with silicon and oxygen. So I consider it only once, one on this side, one on this side. So all I will say is that I have a middle central atom which is bonded by two on the side. Okay, so it has two bond pairs and zero lone pairs. So if a central atom has two bond pairs and zero lone pairs, the shape is going to be linear and the angle is going to be 180 degrees. You have to memorize it. Let's talk about BH3. So let's do the dot diagram of BH3. So boron has 3 valence electrons, so it is going to be bonded by 3 hydrogen atoms. So now I see that my central atom has 3 bond pairs. Okay, my central atom has 3 bond pairs. There are no free electrons like this on boron. Okay, boron has only 3 valence electrons. So my central atom has 3 bond pairs and 0 lone pairs. So if it has 3 bond pairs and 0 lone pairs, the shape is going to be trigonal, planar, and the angle is going to be 120 degrees. So once again, a central atom. This is my central atom. Okay, it has 1, 2, 3 bond pairs and no free electrons here. Okay, 0 lone pairs. Okay, so then the shape is going to be trigonal, planar, and the angle is going to be 180 degrees. If a central atom has 4 bond pairs, okay, if a central atom has 4 bond pairs, 1, 2, 3, 4. So if a central atom has 4 bond pairs, and again, even if there were some double bond or triple bonds, I would only consider it once. If a central atom has 4 bond pairs, the shape is going to be tetrahedral, and the angle is going to be 109 degrees. Okay, so I say 4 bond pairs and 0 lone pairs. So this C doesn't have any lone pair on it. Let's talk about some lone pairs. So I talked about 4 bond pairs on the central atom and 0 lone pairs. 4 bond pairs and 0 lone pairs. Let's talk about NH3. I have, if you pay attention, I have 1, 2, 3 bond pairs, okay, and here is 1 lone pair. So I also told you that the lone pair bond pair repulsion is much more than the bond pair repulsion. So it is going to take more space on the central atom, the lone pair. This one lone pair is going to take more space on the central atom and squeeze the bond pairs inside. So it's going to take more space and it's going to squeeze the bond pairs inside. So you will see that the angle that I had for CH4, which was 109, okay, that angle will go down to 107 because it has squeezed it. This lone pair has squeezed it. So the angle goes down to 107. This is called trigonal pyramidal, and the angle goes down to 107. Now, if instead of having the 4 bond pairs, I had 3 bond pairs and 1 lone pair. Now, if I have water, which has what? 2 bond pairs, 1 and 2 bond pairs, and 2 lone pairs, they're going to take even more space on the central atom, and they will squeeze the bonds even further down. So the angle goes down to 104. Okay, the angle goes down to 104. I call it bent. So you have to see that if you have no lone pairs, the angle is 109. If you have one lone pair, the angle goes down to 107. The shape is called trigonal pyramidal. If we have two lone pairs, they take more space on the central atom. So I'm going to draw it again. They take more space on the central atom and they squeeze the bond pairs inside. So angle goes down to 104. So water is bent, water is not linear. If you draw water like this, it is a wrong answer. Okay, water, this is telling me water is a linear. Okay, it has 180 angle, so this is wrong. Water is bent and it has the angle of 104 degrees. So this is what you need to learn about the lone pairs and bond pairs. So let's do the worksheet here that we started with. Alright, so we will do this worksheet in class together. I mean, if it makes sense to you, you can do it. If not, you just take notes and we will do the worksheet in class. Thank you. See you in class.